So now we have 2014, question 2, part B. So at a glance, this looks like a fairly nice little question. We have two ships, given the speeds of each of them, looking for the relative velocity of B relative to A. Fine, that's all fairly standard stuff. And the exchanging signals, so when they're basically exchange signals for 2 hours, and what is the distance they are from each other. So this doesn't seem too freaky, and actually it's a pretty nice question, but there is just a little bit of weird trigonometry involved in it. So let's crack on. In part 1, we have our two ships, so let's draw them out. B is south of A, so that's A up here, and that is B down there, 300 kilometers south at that. So putting our distances in black. Okay. A is traveling 24 route 2 southwest, so this is actually a really nice thing because southwest means 45 degrees. And it's going 24 route 2, and if you know your causes and sines of 45, you'll know there's a route 2 is involved. So that's going to get a little bit less ugly. And B is going west at 31. Okay, magnitude direction of B relative to A. Well, our normal stuff, velocity of B relative to A, is the velocity of B minus the velocity of A. Okay, so let's lay them all out. The velocity of A is the hard one. Okay, that is 24 root 2 cos 45. Okay, now let's just have a little think of this one. This is going to be minus in both directions because there's a minus j and a minus I. So pop our minus in there. Minus 24 root 2 sine 45. Okay, so that is minus 24 root 2, and that is going to be 1 over root 2. That's 24 root 2, 1 over root 2. You can see how this is about to get very nice. So the velocity of A is minus 24I minus 24J. Okay, velocity of B is just minus 31I going west. Alrighty, let's bring them all together. Velocity of BA is the velocity of B minus 31, and watch your minuses here. Minus 24I minus 24J, which is of course minus 31 plus 24I plus 24J. Velocity BA is minus 7I plus 24J. Now, magnitude and direction. You may recognize these numbers and you may realize that our magnitude is going to be 25. If you don't, no big deal. Let's work on our magnitude of VBA. It's the square root of 7 squared plus 24 squared, which is going to come out to square root of 625, which is of course 25. Okay, so that's the magnitude of them. This is one of our nice little Pythagoras triangles. Now the angle, this is where it can be a little bit annoying. So we're going to do it relative to the horizontal. So if we look at this, we are going across by 7, and we are going up by 24. All right, and that's our angle. We're going to call that alpha. All right. Tan of alpha is of course 24 over 7. So alpha is going to be 73.74 degrees. All right. So you can call that north of west because we're referencing this to the horizontal. That's going to be a little bit annoying in the next step. So 2014, question 2, part B, part 2. Now, we have our two ships. We'll move over here and we'll just redraw our diagram because I'm on a new page. This was ship A. Draw it nice and big here. That's ship B. They are 300 apart. Now, we know from before that the velocity B relative to A is going to be something like this. All right? And the angle we have down here was alpha. Okay, we worried about the closest distance. So we'll do this here at point X. And this is where it just gets slightly annoying because, of course, instead of alpha, I really want this angle here, beta. Now, it's actually much easier than you'd think. And it's worth stopping for a little second. I'm going to draw in a small diagram down here. We got alpha by going across by 7 and up by 24. All right, and we know that the middle bit here, okay, is of course 25, but that's not relevant for the moment, and that's alpha. However, I really want beta, which is in here. All right, well, the tan of alpha was 24/7. But we know here, of course, that that's 7 as well, and that's 24 as well. So the tan of beta is just 7/24. So you can see the relationship between these two guys. Now in this case, it's not the tan of beta I'm going to be interested in, it's going to be the sine of beta, because I know the hypotenuse, I want the opposite. All right, so we know the middle one here is 25. So in this case, the sine of beta, not even going to go into angles, I can get this directly, is 7/25. And that's what I'm going to use in the rest of this drawing equation. Now, so let's come back to this whole kind of thing here. I would like to know AX. Well, sine of beta is AX over 300. So AX is 300 sine beta. And I know that's 7/25. 300 by 7/25. And this is actually pretty nice. So AX is going to equal (84). Now, let's come back and have a look at our question. What are we looking for? They can exchange signals for 2.8 hours, which means it's going to be 1.4 hours this side, 1.4 hours on that side. So let's worry about this side. At this point, they can start to exchange signals. All right, so we'll call this point C here. Start a signal, and this is 1.4 hours from X. All right, point C here. Well, how far is it from there to there? Okay, we know the velocity, the magnitude of the velocity, VBA, is 25 kilometers per hour. So, by 1.4 hours, CX is 1.4 times 25, which equals 35 kilometers. Okay, pop that into a little drawing here. 35. Actually, we know this one is 84. So what are we looking for in our question? Let's go back and double check this one. When they're within D, and of course, this is D here. Okay. From A to C, this is the point at which they can begin to exchange signals. Well, we have 84, we have 35. D is nice and straightforward to get then. So we know that D is in our diagram distance AC, which using Pythagoras, square root of 84 squared plus 35 squared. So D, punch that on your calculator, will equal to 91 kilometers. There we go.